In this video, we're gonna talk about the derivative of the logarithmic function. So first of all, we're gonna begin by talking about the exponential function. We learned how to differentiate exponential function before, and the exponential function is fx equal to a to the x. And we're gonna find the inverse of this exponential function. So the inverse will be given by x equal to a to the y, or you may write this guy in terms of y equal to log x base a. So the pronunciation for this guy is log x base a, okay? And because they are inverse of each other, so we have a to the log x base a turned out to be equal to x. Okay, so a and log cancel like this, and you're gonna see that you're gonna have x left. And the thing that can sit behind the log here will be only positive number. So you have x, and x turned out to be positive. And also you have log a of a to the x. So log a and a will get rid of each other. So you basically just get this x, okay? And this x turned out to be any real number because it's on the exponent, okay? This thing is sitting behind the log, so it must be positive. And when a equal to e, we're gonna write ln. This guy is called natural log. Okay, so this guy is called natural log, or you can read this guy is ln. Okay, so you read this guy. So for this notation, it's gonna be ln. So you can read this one as ln log or natural log. We're not gonna quite say lon for this one. Okay, lon is only for Thailand, I believe. Okay, other country will just say ln or natural log. And I'm gonna say just log because we mostly use only one base, which is the base e. And for base e, instead we're not gonna write log subscript e like this one. Okay, so we're not gonna write log subscript e, so we're gonna write ln for this one for the shorter notation. Okay, and we will have normal property of the log. So the first one will be log of the product. So you have log of the product turned out to be the sum of the log. So this one is log of the product. And the second one is log of quotient. So you have log of the quotient turned out to be the difference of the log. Okay, so you have the log of the product and log of the quotient. And you have log w to the z. So you have log w to the z. You'll be able to like move z down here. So you're gonna end up with z log w. Okay, so you end up with z log w. And you have log e equal to 1 and log 1 equal to 0. These are the common value of the log. So we have, in general, log a base a equal to 1. So in this case, we have log e base e equal to ln e equal to 1. Okay, and log 1 equal to 0. So log 1 any base, so it's going to be equal to 0 as well. Okay, and finally you have e and log will cancel each other out like this, and you're gonna get z. Okay, so e to the log z is gonna turn out to be z. For example, if you have e to the log 2, is going to be 2e to the log root 3. So it's going to be root 3. Okay, so this one is going to be the important algebraic property of the log function. So please memorize the property of the log. Log of the product turn out to be the sum of the log. Okay, log of product equal to sum of log, and you have log of the quotient is going to be the difference of log. Okay, the next one we're gonna find the derivative of the log function. So we will find the derivative of y equal to log x base a. Okay, so we want the derivative of this green function y equal to log x base a. So we use the implicit differentiation again. We have y equal to log x base a can be written in terms of x equal to a to the y, and then you're gonna differentiate this guy both sides. Okay, so you would get what? So you would get dx equal to 1 for the left side, and you're gonna get dx of a to the y for the right side. And you be able to differentiate a to the y implicitly. So it's gonna be a to the y log base a, log a base e. Okay, so it's gonna be a to the y log a base e y prime. Okay, so it's gonna be this one. And for this one, you're gonna be able to solve for y prime. So you have y prime equal to 1 over a to the y log a. So, and 1 over a to the y log a, you may have to know that you have a to the y equal to x. So you have y prime equal to 1 over log 1 over x log a. So this is the derivative of log x base a. Derivative of log x base a turned out to be 1 over x log a. Okay, so it's going to be 1 over x log a. And in the case that a equal to e, so when a equal to e, we have log a, so it's going to be log e equal to 1. So in this case, you're going to see that we're going to have a much simpler formula. So you're going to have dip log x, okay? Dip log x base e in this case turned out to be just 1 over x. So you see the difference here, we not have the factor log a because it disappears because log e equal to 1, okay? So this is what we have for deep log. Okay, so if you have base A, you see that the base A will come down here for LNA. However, if you have base E, this guy will be just 1 over x. It make your formula nicer. Another one will be if you can apply the chain rule for the log function. If you dip log u base a, it's going to be, you see that it's going to be 1 over u. Okay, so it's going to be 1 over u log a, and you dip inside. So this is the reason why you get u prime x on top. So this guy is coming from dip inside. Okay, and similar thing, if you have a equal to e, so it's going to become log e, and log e disappear, so it's going to be just u prime over u. Okay, so you dip log ux is going to be u prime over u. Okay, so this is important. Let me circle this one also. So the important one turned out to be this one. Okay, so dip log u is going to be u prime over u. Okay, and we're gonna use this one next. Let's try to apply the formula. So you have fx equal to e to the x plus log x plus 1 plus x. You like to find the tangent line at x equal to 0. So you will need slope at x equal to 0. So we're gonna find f prime 0. Okay, so we're gonna find f prime 0. So you have f prime 0. Okay, so you have f prime f. First you need to find f prime x, not f prime x. You dip e to the x, you get e to the x. You dip log 1 over x, so it's going you dip log x plus 1, it's going to be 1 over x plus 1, and you dip x, you get 1. Okay, so you have f prime 0. Okay, so you have f prime 0 equal to e to the 0 plus 1 over 0 plus 1 plus 1. So it's going to be 1 plus 1 plus 1 equal to 3. Okay, so you have the slope equal to 3. Now we need one point. Okay, so the point turn out to be f0, and f0 is equal to, let me change color. The point in this case is f0, so it's going to be e to the 0 plus log of 0 plus 1 plus 0, so it's going to be 1. Okay, so the point will be 0, 1. Okay, and you may just have the tangent line will be just using the Poisson form. So the tangent line will become y minus 1 equal to 3x minus 0. So you have y equal to 3x plus 1. Okay, so this is how we have the tangent line. Okay, so y equal to 3x plus 1. The next example asks you to find the dx of log absolute x. Okay, so you see that the important part for this question will be you need to get rid of absolute value, and we're gonna just apply the normal trick. So we learned before that absolute value of x turn out to be x if x positive or 0, or negative x if x negative. Okay, so you get log absolute value of x turn out to be log x if x positive, and it's going to be log of negative x if x negative. Okay, so you see that we don't have to care about 0 because we already know that log 0 is undefined. Okay, so we remark that log 0 is undefined. Okay, so we don't have to care about at x equal to 0. So when you have the piecewise function like this, you're gonna differentiate. So you're gonna have the dx of log absolute x. So you basically dip the dx of log x if x is positive, and you have the dx of log of negative x if x negative. Okay, and so this guy will be 1 over x if x positive, and it's going to be negative 1 over x if x negative. Okay, so this is what we have. Okay, and sorry, I forgot one thing. So I have negative. Okay, so I have 1 over negative x, and you're gonna have to differentiate. Okay, the dx of negative x Okay, so this guy will become -1. Let me write in this way. So it's going to be -1, and this guy -1 come from div -x. Okay, and in this case, this guy will be just 1/x if x negative. So you see that it turns out we have for x positive and x negative, you get the same number. So you get the same 1/x for both x positive and x negative. So in this case, we may conclude that you have the dx of log of absolute value of x turn out to be just 1/x, and the condition that we will have is going to be just x cannot be 0 because log 0 is not defined. Okay, so you're gonna have this one for the formula. Let me box this one. This one is important, and we're going to use this one quite a lot. So the log absolute value of x turned out to be 1/x. Okay, so this one, the emphasizing one is going to be just we have absolute value. Okay, so for this one, you see that after you differentiate, you're not going to get absolute value. Okay, the log absolute is going to be just 1/x without absolute value. Okay. Okay, so we're gonna try to find derivative of log of square root x cubed plus 1. Okay, so in this case, don't differentiate this thing right away. So you should write this one as log of x cubed plus 1 to the 1/2, and you use the property of the log, so you can bring 1/2 down, so this guy will be 1/2 log x cubed plus 1. Okay, and you have y prime. Okay, so you have y prime, so you dip 1/2 log x cubed plus 1. So this one is gonna be your u. So you like to dip log u. Okay, so you dip log u is gonna be u prime over u. So it's gonna be, you're gonna write u prime. So it's gonna be x cubed plus 1 prime over u, which is x cubed plus 1. Like I said, this is how we have the correct formula, and this thing turned out to be 1/2. Okay, and dip x cubed plus 1, so you get 3x squared over x cubed plus 1 on the bottom. Okay, so this one will be the derivative that you're looking for. Okay, another one is gonna be, you have log base 3 of absolute 2 minus sine x. So in this case, you're gonna differentiate by, so this guy we have log, we're gonna use one property of the log. It's called chain of bases. So it's called chain basis of log. Okay, so it's called chain basis of log. So in this case, you see the chain basis of log means that when you have log b base a, okay, so when you have log b base a, this guy will turn out to be ln b over ln a. So this will allow you to change log any base, okay, so this one is base a, into log base e. So this allow you to change log of any base to log base e. So in this case, you have log base 3 of absolute 2 minus sine x. So in this case, you're gonna have log okay, of the whole thing here. So it's going to be log of absolute 2 minus psi x over log 3. Okay, so you have log absolute 2 minus psi x over log 3. And this guy is a constant. Okay, so this one become a constant. Okay, so derivative that we gonna have turned out to be, so you dip y, okay, so it's gonna be constant, so you just pull out constant, and you basically dx of log absolute 2 minus psi x, and this guy will be 1 over log 3, and you dip this one. Okay, so you dip log is going to be what? It's going to be 2 minus psi x. Okay, and you differentiate the inside, so it's going to be 2 minus psi x prime without absolute value. Okay, so without absolute value in this case. So in this case, you gonna get 1 over log 3. Okay, and you have negative dip side, you get cos. Okay, and you have 2 minus psi x on the bottom. Okay, so this one will be your final answer. Okay, so we did 2 examples, and I introduced you to the basic property of the log about the chain of bases. The next one, you see that you have log base 5x and of arctan of x squared. Okay, so it's going to be this one. And you see that you use chain of bases. Okay, so you will use the chain of bases to write this one. Okay, so you use chain of bases to write this one as, you're gonna write it as ln r tan x squared over ln 5x. Okay, and you're gonna find y prime, so you're gonna differentiate this guy, so it's gonna be d dx of the whole thing here. Okay, so you're gonna have this one, and when you differentiate this one, you're gonna use the quotient rule. So this one is the quotient between two functions, and you use the quotient rule, so you have the bottom derivative of the top and of x squared, okay, minus the top derivative of the bottom over the bottom square. So it's going to be log 5x squared. So in this case, you're going to have, okay, let me write this one bigger. So it's going to be, let me write the line first. Okay, this one, not quite like it. Okay. I cannot draw a line. Okay, so in this case, you're gonna get, that's fine. So in this case, you're gonna get log 5x. Okay, dip log arctan is gonna be 1 over arctan. So you dip arctan x squared and over arctan x squared. Okay, so this one is dip log arctan x squared. and you have log arctan x squared, and you dip log phi x, so it's gonna be phi x down here, and you have dip phi x. Okay, so in this case you're gonna have, it's gonna be log phi x squared on the bottom. So in this case you're gonna get log phi x, okay, and dip arctan x squared. So be careful a little bit. This is arctan of x squared. So it's going to be 1 over 1 plus x squared square. Okay. It's not quite nice. Let me write this one nicer. 1 plus x squared square. And you dip the inside, you get 2x. Okay. Minus log of 10 x squared. Okay, and by the way, don't forget, I already forget, so this one, don't forget the thing that you have on the bottom. Okay, you have the green guy on the bottom, so let's put this thing on the bottom. So it's gonna be 10x squared. Okay, so this one is the green guy, minus log of 10 x squared, and you dip phi x is gonna be phi and phi x. Okay, and you see that these two guys can be cancelled, phi and phi. Okay, so you basically just get 1 over x, and everything here will be over log phi x squared. And this will be your final answer. Okay, it's kind of long calculation here. Okay, so the difficult part, I would say that it's gonna be this term. So differentiate this term, that you may have to pay attention a little bit. What you're gonna get is gonna be 1 over x to the 4th times 2x. Okay. Last thing, it's gonna be the technique of differentiation. This thing is a technique of differentiation. So I'm gonna say that it is a technique of differentiation. So what is it? Why we call this thing the technique of differentiation? It is called logarithmic differentiation, and we're gonna use the log and the derivative of the log function in order to find the derivative of the given function. So it's gonna consist of several steps. The first step will be you're gonna take log both sides. So you're gonna take log both sides of the relation and use the property of the log. Okay, and use the property of the log. The property that we're gonna use turn out to be the simple one. Log of the product turn out to be the sum of the log. Log of the quotient turn out to be the difference of the log, and log of a to the r will be equal to r log a. And you're gonna implicitly differentiate with respect to x. Okay, and one thing to recall is gonna be when you dx of log y. Okay, so ddx of log y is gonna turn out to be y prime over y. Okay, so this is what we have learned earlier, and then you solve for y prime. Okay, and we're gonna have another technique. So let's do number 1, number 2, number 3 first, and then I'm gonna go back to this technique. Okay, so we have this one. We have y equal to x to the 3/4. Okay, so you have x to the 3/4, square root x squared plus 1 over 3x plus 2 to the 5th. So in this case, you're gonna take log y both sides. So you would have log y equal to, okay, so let me copy this thing. I'm not gonna copy, I'm gonna just take log. Okay, so I take ln both sides like this. Okay, so I basically take ln both sides, and I will have log y. Let me, so it's gonna be log y equal to, okay, and you use the property of the log, you would get log x to the 3/2, okay, and this second term will be add log x squared plus 1 to the 1/2, and you minus log 3x plus 2 to the 5th, okay, and then you see that this guy will be 3/4 log x plus 1/2 log x squared plus 1 minus 5 log 3x plus 2, okay, and this one will be log y, okay. So after you have this one, you're gonna differentiate both sides, okay, so you differentiate both sides. The thing that you will get will be, you get y prime over y, okay, you get y prime over y, and you get 3/4 dip log, it's going to be 1 over x, easy. And the second one will be 1/2, and you have dip log x squared plus 1, so you dip x squared plus 1 on top, and you have x squared plus 1 on the bottom. And finally, you have 5 down, and you dip 3x plus 2 on top, and you have 3x plus 2 on the bottom. So in this case, you get 3 over 4x plus, it's going to be 1 over 2 times 2x over x squared plus 1 minus 5 times 3 over 3x plus 2. So you solve for y prime. So it's going to be 3 over 4x plus, okay, 2 and 2 cancel. So you get x over x squared plus 1, and you have 15 over 3x plus 2, okay, and you see that you have y prime on this side, okay, so you have y prime on this side, so you're gonna multiply the whole equation by y prime, so you allow to move this y prime, a whole equation by y. Okay, so this one will be your final answer. And you may ask me, hey, it's not an final answer because it's not in terms of x yet. Of course, it's gonna be, so if you like to have the final answer in terms of x, so you're gonna just write everything again. Okay, so I may copy this one. Let me just copy this thing. I copy this one and I paste it here. And this guy, okay, so let me have this one, and this guy will be equal to, okay, this guy will be equal to y equal to what? Y equal to the one here, okay, so y equal to this big term. So you basically copy the big term down, so it's gonna be x to the 3/4 and square root x squared plus 1 over 3x plus 2 to the 5. Okay, so this one will be your final answer. So this one is your y. Okay, so this one is the derivative that we have. So you see it's going to be consist of two steps. The first step, I use the red color, so you take log both sides and simplify. The second step, you're gonna have differentiate, okay? And the third step turn out to be you solve for y prime. So this one is the thing that I said it's gonna be 1, 2, and 3, okay? Now, so let me enlarge this one. Now for the second one, it will be the same trick. You're gonna take log both sides. Okay, so you're gonna take log both sides like this, and you're gonna use the property of the log. So it's gonna be log y equal to log x squared plus 1 cube minus log pi to the cos x minus log arc psi x. Okay, and you have log y equal to 3 log x squared plus 1, and you have cos x log pi, okay, and you have log arc psi x. And then this one is your first step. The second step will be you're gonna differentiate the whole thing, okay? So you differentiate log y is gonna be y prime over y, okay? So you should be able to do this right now. And you differentiate 3 log x squared, okay? So you see that after we use the property of the log, this guy come down, okay? And you have cos x log pi. So it's going to be 3 and you differentiate. So you have x squared plus 1 prime over x squared plus 1, okay, minus you differentiate. So this log is going to be constant. Log pi is constant. So you're going to dip cos, you get negative psi. And you have log arc psi. So it's going to be arc psi down here, and you have arc psi x prime, okay? So in this case, you will get 3 times 2x over x squared plus 1 plus psi x log x, okay? And you dip arc psi is going to be 1 over square root 1 minus x squared, and you have arc psi x, okay. So this one is y prime over y. So in this case, you get y prime equal to 6x over x squared plus 1 plus psi x times log x minus, you get 1 over square root 1 minus x squared arc psi x. And this thing will be the whole thing multiplied with this y, okay? So you see that you're gonna multiply with this y to obtain your final answer. However, if you want this one to be in terms of x, okay? So if you want this one to be in terms of x, you may have to copy x. You may have to copy x squared plus 1 cube over pi to the cos x arc psi x. Okay, so this is how we have for question B. So this one is your second step, okay, and this one is your solve for y. It will be your third step, and the final answer is right in front of your right. The next one will be y equal to 2x plus 1 to the x squared. So this one, I'm gonna say that this one is gonna be function in x, so it's gonna be function fx to the gx. So it's gonna be in terms of the one that kind of feel complicated. Okay, so when you have fx to the gx like this one, you're gonna apply log both sides in order to bring the function down. Okay, so you're gonna take log both sides. Why we taking log both sides? We taking log both sides because if you take ln both sides like this will allow you to bring x squared down. So you get log y equal to x squared log of 2x plus 1. Okay, and this will allow you to differentiate. Okay, so you gonna differentiate this term, so you get deep log y is gonna be y prime over y, and for deep of x square log x plus 1, so this guy is product. So you're gonna have the first derivative of the second plus the second, which is log 2x plus 1, derivative of the first. So it's going to be what? 2x. Okay. That's it, actually. And then what? And then this one will be x squared, okay, and times 2 over 2x plus 1 plus log of 2x plus 1 times 2x, and everything multiplied with y, so it's going to be multiplied with 2x plus 1 to the x squared. So this one is y prime. Okay, so this one is your y, and you multiply y up here, okay, in order to solve for y prime. Okay, so you see it's gonna not difficult. However, here that you apply the product rule. Okay, another one, you have y equal to the fourth root of x to the 10x. So this guy, if you write this one, it's gonna be x to the 10x over 4. Okay, so this can be written as something like this. So you gonna just take log both sides. So you have log y equal to log of x to the 10x over 4. And this guy will become 10x over 4 times log x. And then you differentiate this one. So you differentiate this one. So you get y prime over y. And you have differentiate this one is going to be again product. Okay. So it's going to be the first derivative of the second plus the second derivative of the first if 10 is 6 squared. Okay, so in this case, you're gonna solve for y prime. It's gonna be 10x over 4x plus you have log x times 6 square x over 4, and you multiply with y, so you multiply with the fourth root of x to the 10x for your final answer. Okay, so this one will be the derivative by using logarithmic differentiation. However, for question C and question D, when you have function to the function fx to the gx, okay, when you have function to the function, you're gonna have other ways to do this one by writing. So if you see this lecture, you have fx to the gx, you'll be able to write this one as e to the gx log fx. So we recall something first. I told you before at the beginning of this lecture that e and log cancel each other. So we have fx equal to e to the log of fx. So you're gonna have gx. So you raise this guy to the gx. So you raise this guy to the gx. So this is the reason why do we have f to the gx turn out to be e to the gx log fx. And when you differentiate, you'll be able to differentiate fx to the gx turn out to be written as e to the gx log fx. And we just apply the derivative. This one is not going to be function to the function anymore. It's going to be just product. So you'll be able to do it in other way. Let me do this one in other colors. I'm gonna do in the second solution. Okay, so I give you the second solution somewhere here. Let me copy the question first. So it's gonna be y equal to 2x plus 1 x squared on top. So this one, you see that it is fx to the gx. So let me highlight. So this one is going to be the pink one, and you have the yellow one on top. So in this case, this guy will be x squared log. Okay, so this guy can be written as e to the x squared log of 2x plus 1. Let me here and here. Okay, so it's gonna be fx to the gx. Okay, so it is fx to the gx. So it's gonna be gx log fx. Okay, so this is what we hear or what we see in the previous page. So we write fx to the gx in terms of e to the gx log fx. Okay, and this one allow you to find y prime directly from the exponential rule. So you see that you're gonna dip this guy, so dip e to the u. Let me recall you to differentiate e to the u. So when you dip e to the u, it's gonna be e to the u du dx. Okay, so dip e to the u is gonna be e to the u du dx. So in this case, it's going to be e to the u is the whole thing. Okay, and you have du dx, so it's going to be d dx of x squared log 2x plus 1. And you see that it is e to the x squared log 2x plus 1. And you dip this guy, okay, by using the product rule. So this one is the product rule. So you use the product rule to differentiate this term. So you would get the first, be careful when you write it down, derivative of the second. So it's going to be 2x plus 1 times 2 plus the second derivative of the first. So it's going to be 2x. Okay. And you get y prime. Okay. And for this term, okay, so and for this term, e to the x squared log 2x plus 1 is gonna be come 2x plus 1 to the x squared. Okay, so this one is right on the first line. Okay, so this one is the green guy. So you see the green guy is, I just copy the green guy down. Okay, and you see the back here is going to be 2x squared over 2x plus 1 plus log of 2x plus 1 times 2x. Okay, so times 2x like this. I would want you to compare the solution. So I would like you to compare this solution. So you have these two solutions here, and you see that one way is taking log both sides. Another way is to rewrite this expression in terms of e to the something. You see that it's going to be the same thing, okay? And it's going to give you the final answer it is the same final answer. So you see, it's going to give you identical final answer. However, this one is you use algebraic trick and you end up with using the product rule, the same thing, okay? I'm not gonna say that this one is easier than this one. It's gonna be the same thing. However, sometimes when you are dealing with the expression that you're not allowed to take log both sides, this one will be shorter. I'm gonna give you the example in the next example, okay, to see whether we use the green guy here and it's gonna make our life easier. Let's do one more. For this one, you have y equal to the fourth root of x to the 10x. Okay, so in this case, it's going to be x to the 10x over 4. Okay, and you see that this guy can be written as you have the function f on the bottom, you have the function g on top. So this guy will be e to the 10x over 4 log x. Okay, so it can be written in terms of exponential function in this form first, and then you differentiate this guy. So it's going to be the whole thing. So it's going to be dip e to the u. So it's going to be e to the u. And you're going to have to dip 10x over 4 log x. Okay. And here you're going to have e to the 10x over 4 log x. And you dip 10x over 4 times log x is going to be the first derivative of the second plus the second derivative of the first. Dip 10 is 6 square x over 4. Okay, and so you get this one, and like I told you before, this one is the green function. Okay, so this one you use the green function here, and this guy turned out to be the question basically. So this guy will be the fourth root of x to the 10x. Okay, and you copy the rest of the term down. So in this case, it's going to be 10x over 4x plus log x multiplied with 6 square x over 4. Okay, so that's all. Yeah, you see the same solution, same final answer. Okay. However, for this one, I'm not gonna say it's shorter because it is the same thing. The thing that you see also that, hey, we use the product rule again. Yes, of course we did use the product rule. Okay. The reason why I say that the second way or the second solution will be more useful is going to be as follow. Okay, so let me move this guy down here. Because sometimes you see that you not be able to take log for these two guys. Okay, so you not be able to take log because log cannot be like so if you want to take log here, log of the sum, we don't have that. Okay, so we have only log of the product. So in this case, we gonna do what? We gonna try to change this term. Okay, so I'm gonna highlight this one is a pink one and this guy is the yellow guy. So I'm gonna change this one to this one turn out to be e to the y log x. Okay, so this guy turn out to be e to the y log x, and this guy turn out to be e to the x log y. Okay, equal to, okay, so you add these two guys equal to x sine y, and you differentiate both sides. Okay, so you differentiate both sides. So you dip e to the y log x, so it's going to be e to the y log x, and you dip y log x, okay, plus e to the, let me change the color, why I didn't, let me change the color a little bit. This one I should use the red one, right? Use the red one. And for the second one, I use the green one. So I'm gonna add this guy. So I'm gonna use the green one. So it's gonna be e to the x log y. And you have x log y prime. And on the right side, you see that it's gonna be dip x sine y. So you use the product rule. So this guy is the product. So I'm going to use the product rule. The first derivative of the second plus the second, which is sine y, derivative of the first, which is 1. Okay, so this one will be the product rule. And then you're going to differentiate the red guy. So it's going to be e to the y log x. Okay, and dip y log x is going to be the first derivative of the second plus the second derivative of the first. Okay, so that is the red one. And you have derivative of the green one. So it's going to be e to the x log y. Okay, and here is going to be the first derivative of the second. Dip log y is y prime y plus the second. So it's going to be log y derivative of the first. And this guy will be equal to x cos y times y prime plus psi of y. Okay, so this is what we have so far. And then what? And then we gonna solve for y prime. So we solve for y prime. So how many terms do I have? I have 3 terms in this case. So we gonna solve for y prime. So you solve this one for y prime. It's gonna be, before I solve everything to y prime, let's change some term back. So you see that this term is the pink one. Okay, so this one is the pink one. Okay, so this one is the pink one. So the red one is the pink term, and the green one is the yellow term. So for this one, it's gonna turn out to be equal to x to the y. Okay, and this guy turned out to be y to the x. Okay, so let me highlight this one. So it's gonna be the yellow guy and the pink guy. Okay, and then what? And then we're gonna gather y on one side, and we're gonna gather y prime on the other side. Okay, so we're gonna gather y on one side, and we're gonna gather y prime, sorry, the term without y prime on the other side. So in this case, you get what? X to the y log x, okay, y prime, okay, and you have y to the x times x y prime over y. Okay, so it's gonna be like this, and you're gonna have minus x cos y times y prime. Okay, so you get three terms on the right, and you're gonna move. Okay, so you have sine y on the right side already. Okay, so you have three terms on the left side, and you're gonna have another one on the right side. So in this case, it's gonna be minus x to the y, y over x times y over x, and finally you get y to the x log y. Okay, so you have y to the x log y for your final answer. So in this case, you're gonna get, okay, so let me check. Is correct, yeah. Finally, you're gonna solve for y prime. So you are looking for the green one. Okay, so you would get y prime equal to, you see, you copy everything on the right side down. So it's going to be x to the y over x minus y to the x log y. Everything is over x to the y log x plus y to the x times x over y minus x cosine y. Okay, so this is how we have the y prime, okay, for this question. Okay, so I think I did everything correctly, right? So it's gonna be y to the x log y. Yeah, this should be, yeah, it should be correct. So you see, the important one will be, you see that this one we not allowed to take log both sides. Okay, we're not allowed to take log both sides. However, we do this one by changing x to the y to e to the y log x, and changing y to the x to e to the x log y. Okay, and this will allow you to be able to find y prime. Okay, so it's going to be that. So it's going to be useful for this method or this method. Okay, so you have two choices in order to find derivative, and this thing is called logarithmic differentiation. Okay, so this technique is called logarithmic differentiation. Okay, so I think that should be it for this one, and the next one will turn out to be application of derivative now.